So Kyle, you let us know when to start. We'll give a few minutes for people. Some people might be a few minutes late, so we'll maybe start at 5:04 or 5:05 or something, do you think?
Yeah, yeah, 5:04 sounds good.
Okay.
Around that. Yeah, I just put another update with the Zoom link for people to jump on, so all right. But yeah, so just awesome.
Hey, Marcus.
Let us know, Kyle, when to get started. This is Deepak here.
Okay, sounds good.
You know, because once we get started, we are roaring like anything. So
Good.
now this is going to be a fun session.
So I see, Kyle, that there are, I guess, 3 people are recording. Is that true? Oh, I think only one person is recording, but because we are co-hosts, then it just shows that we are recording too.
Yeah,
Yeah, but I guess it's in the cloud, so it's okay. As long as, you know, it gets recorded, we're fine.
yeah. I think that'll be fine. Okay, now we just 2 or 3 more minutes.
Yeah.
And people who are just coming in, make sure you go through the steps on this slide that's kind of up right now, just to create an account and download the data sets, and then
Yeah. So at some point, Kyle, you will have to make Pranay the co-host, because he's the one who's going to be leading the workshop.
Okay, and sorry, hit it again.
Pranay.
Oh, I see him. Okay, I'll make him the co-host now. Because I think you can have as many co-hosts as you want.
Okay. Yeah, Zoom did a lot of enhancements, you know.
Yeah.
So how did you get into machine learning, Kyle?
I'm personally not actually super, I guess, deep into machine learning at this point. Some of what I've like studied so far has been around like computational biology and some of the machine learning and structural computational biology. But I'm going to be a senior next year, and I'm still, yeah, kind of seeing what I can do with it and seeing how I can.
Yeah, I mean,
I'm not super into it at this point, I would say.
But that's okay, because you are the ideal audience for EazyML.
Yeah.
You needn't be an expert in data science with a bunch of courses in statistics to say, oh, now I can do machine learning. And that's the usual connotation that goes with it. But that needn't be the case. Because if, after all, the machine is intelligent as it claims to be, then why can't it walk you through? So that's the intention here. It's typical for an audience like you, which is, I have my area in which I specialize in your case, maybe computational biology. And I'd like to use machine learning as a tool to help me there, but I don't want to become an expert in it necessarily, but I do want to use it for furthering my research in my area of expertise. And so that's precisely the sweet spot for EazyML.
Yeah. Mita gave me access to the software, and I've been looking through it, and it definitely seems exciting and helpful. So I'm looking forward to this workshop, and I think, you know, as I said, for anyone who can't make it, at least I'll have access to the recording, and you know, I'll make sure we can reach out to y'all with other questions or not if you guys are open to that. But yeah.
Yeah.
All
So
right.
the idea is after this workshop, You're going to be crazy about machine learning, Kyle.
Absolutely. Awesome. Okay, so everyone who's coming in, I just put in the form again into the chat. Just make sure to fill that out so you can get access to the software after. And I think now we'll kind of get started. So hello everyone from the Phoenix Project, and other groups. Thank you all for coming today. I'm really excited for this workshop, and yeah, I'll leave it off to the guys at EazyML. Go ahead, you guys. Thanks.
All right, well, thank you. Thank you so much, Kyle, for organizing this. We're so happy to be invited to host EazyML workshop for Duke University students. I think it's a pretty good turnout considering, Kyle, it's beautiful outside. Everybody is choosing to learn machine learning instead of going out, so that's pretty good.
Yeah.
So before we start the workshop, I just wanted to go over a few housekeeping stuff. I just wanted to make sure, I hope everybody has created their account on the EazyML platform and downloaded the Titanic training data set and the test data set. If you haven't done so, please do so immediately, because you can just get a lot out of this workshop if you have already created your account and have the data sets handy. So that's one. We are recording the workshop, and Kyle is going to make available to you. So if for some reason, some of you cannot follow the entire flow, you missed something, just stop and maybe just watch it, and you can come back to it when the recording is available. Probably that would be a good strategy to really understand and learn machine learning through this platform. If there are any questions, please feel free to post it on chat. My team is going to continue to answer the questions, and also we are happy to, if we go over time, we are happy to stay back, or if we are done before time, we are happy to answer all of your questions. I have made my email available at the chat. If there is any questions, please feel free to reach out to me. I also wanted to mention that for the students who are interested after the workshop, we will be very happy to give them free premium access for a month. If you want to learn, just reach out to me. Again, my email ID is on chat. Just let me know or let Kyle know, and we'll be very happy to extend you free premium access for a month so you can continue to try EazyML and see what you think and learn machine learning. Also, we do hold competitions, and we have prizes for students who come up with excellent use cases for EazyML. So stay tuned for that. We'll be announcing all that on our website. And last but not the least, there is a gender disparity in technology. Only, I think, about 17% of women pursue career in technology at the university level. So women are really underrepresented in technology. So if there are students, female students from other majors who are attending the workshop, majors from social sciences, natural sciences, and you want to learn machine learning, and you think that, you don't know coding, how do you get started? Well, this is the ideal platform for you to get started with machine learning. You don't need to learn coding to get started. EazyML has really made it very, very easy to learn machine learning. So that was one thing I wanted to mention, that if there are students from other disciplines as well, please reach out to me if you are finding it very challenging even after the workshop, and we'll see how we can help you. So I think I'm going to start off by sharing my screen. Kyle, can I share?
Yeah, I'll just stop sharing.
All right, so you can see my screen, right?
We could, but I think you unshared.
Oh. Okay, so you can see my screen now.
Yep.
All right, perfect. So I just want to give a quick tour of EazyML website. There is an enterprise version and there is a personal version. You guys are going to go to the personal version. You click. I would encourage all of you to go to the tutorial section. There is a data repository. It is curated data. You can go to the data repository and you can just get started immediately after the workshop. I would start with the beginner. There is training data, test data downloaded. There is description about each of these use cases. And as you become more comfortable, you can go and try medium data sets. And then there are large data sets. And then there are some public data sets. So just take a look at the data repository, which is a curated data set that is tested on EazyML, and it will help facilitate your learning. And the most important thing is I would encourage you to go to tutorial section and just watch some videos. It has really good content and we continue to post more content. There are some videos, some PDF, some basic information, some advanced information. See what you like and it's going to help you just understand and get started.
If you look, it's very laid out very systematically. The first part of tutorial starts by saying, why even bother doing ML, machine learning, right? So let's say you are convinced by looking at some of these videos, reading elsewhere, then the next thing says, okay, should you consider EazyML platform for machine learning? After all, there are so many others. It's a candidate. Evaluate it. If this works for you, then please do. And if you selected EazyML, then it says, here are some of the nice features about it. And to help you get started on this journey. And so now you're scratching your head. You're saying, okay, I'm sold. I look at the platform. I want to use it, but how do I get started? Well, a bunch of use cases with training data, test data to help you get rolling. And like Meeta said, for the female students and the male students, so that we're gender neutral, and the male students.
No, I'm gender biased.
Okay, all right. For everyone here, should you be scratching your head, which happens quite a bit. It's like, okay, how do I get started now? Don't hesitate to reach out to us. If there is considerable interest, we would be very tempted to do a follow-on session to show you, here's how you get started. Although this is a workshop, you will be doing precisely that, but a follow-on session is certainly in the cards if lots of people request.
Yeah, and by the way, we did, predict COVID-19, when would it really recede, and it was pretty close. It was pretty close. You guys should check it out. And then there is an app store. If you want to build your own apps, sentiment analysis, concept extraction, and topic mining. The sentiment analysis is available in the web form, GUI form. The others are on API. So, and then we have a developer portal as well, which Pranay is going to get into. But I just wanted to give you a sense of how much resources we have on the website, and it would be very beneficial for you guys to go and take a look at that. And then, as I said, we'll be happy to extend to interested students the premium subscription. It would really allow you huge data sets. Even though it says 8,000 rows and 50 columns, it goes really beyond that. Don't tell that to anybody. So I guess I will now, I'm just going to be quarterbacking. I'm going to give it to Deepak now, who's going to give an introduction, a little introduction about the company and EazyML and what it is and what are the differentiators. And then we are going to give it to Pranay, who is going to be leading the workshop. So guys, Deepak is the CEO of EazyML, and Deepak, you are up now. You want me to stop sharing?
No, yeah. Right, people can see this, our unique value proposition, right? Okay, great. And by the way, that right-hand top corner, that pi symbol, it's Greek letters are my favorite. So that's the EazyML symbol. So thank you, Mika. It's like, oh no, not another machine learning platform, right? There is Google's TensorFlow, AutoML, Microsoft Azure Studio, AWS has one, Amazon that is. There are startups like H2O, Data Robot, Big ML. Boy, it's all over the place. Like yet another, again, another one. Why? All these platforms that I rattled off are for data scientists. So if you are not well versed with data science and its methodology, your effort will not be as fruitful. In addition, it will be very tiring. You will be guessing stuff. So the question for us fundamentally was, if this machine learning says it's an intelligent statistical machine, then why can't it bootstrap itself without giving the user a heartache in terms of various technical aspects? Hence EazyML. It is easy to use, and in that sense, it is meant for everyone, not just the data scientist. So you are a psychology major, collecting data for your experiments, and now you want to build an intelligent machine out of it that can predict the outcome, whatever you're trying to predict about an individual based on various observations that you've made. Well, it's possible. It democratizes machine learning. So easy to use. I'll give you one aspect. You will see with Pranay, but machine learning again has lots of steps, outliers and imputation. It just goes on and on and on, right? Which step to execute and what order to execute, what parameters to select at each step. All of it is machine has researched that for your specific data so that you don't have to mind-numbingly research. You can use it as a user who's interested in building an application. Not so much, oh, first let me learn data science, then I can weave my way around this ML. Transparency, the next big thing. I'm sure you guys have heard there's so many flavors of different models, statistical models, right? And it's getting increasingly complicated with deep learning frameworks. But the challenge is that these complex models are black boxes. They don't tell you why they are predicting the way they are predicting. So, can you trust? Even if it's right, can you trust a machine that's saying, hey, believe me, I got it right? Like, why do you say that? I don't quite understand. No, just believe me, it's right. No need for me to explain. That's a stillborn experiment. EasyML, in keeping with its easiness, is transparent, almost to a fault. It's going to tell you everything about what it's doing to your data, why it's predicting the way it's predicting, and you will see all that. And last but not least, stuff at the bottom here, text analytics. It's a fact that, and I'm sure it's the case at Duke University, elite institutions like Duke, that you guys read a lot. And most of the reading is in a natural language. I suspect English in this case. And when you read, it influences your thought process. Subliminally, it stays somewhere with you. You know that yellow highlighters that you do? Those are the key points that stay with you and influence decision making. Whether you realize it or not, they're there influencing your thought process. Now, look at the poor machine or this any machine learning platform. It's geared towards numeric data. So a whole slew of textual data that is so influential in how humans react to stimuli, events, predict stuff, forecast. The machine is oblivious to all that richness of information. EazyML makes a very focused attempt to become intelligent about textual data, not just numeric data. You'll see that as well. I'll give you a real life use case. Let's say you are a marketing major, right? And let's say as a digital marketer, you've been hired by I don't know, Johnson & Johnson to study what the how receptive the market is to their new sanitary wipes that are deadly for wiping out COVID infection. So you wipe the surface and it guarantees that any COVID remnants will be wiped out. Okay, and Johnson & Johnson contacts you and says, hey, could you evaluate how that new product rollout is being received in the United States or globally? So you have access to feeds. People are talking about it, social media, blogs, all that stuff. And tons of people are talking, tons of different things, Twitter, etc. Can you take all that and pump it to a machine and say, hey, show me the trend. How are people reacting to it? What sentiments are they expressing? Positive, negative, bullish, bearish, neutral, and how it's trending as time goes on. Worth its weight in gold. See how powerful text analytics can be? Again, this platform is very, very cognizant of the power of textual analytics. So the question is, how the heck did we get to be, oops, sorry, I just pressed it the wrong time. How the heck did we get to be so adept at natural language processing? So I'll give you a brief 1-minute stuff and then I'll turn it over to Pranay. So EazyML traces its lineage to a medium-sized entity headquartered in New York, probably going to be IPO'd later this year, called IPsoft, right? And IPsoft, and these are some bunch of famous analysts like Gartner and Forrester, etc. Right? And so they are evaluating how natural language processing, which is what is a very core subset of what we call text analytics. So how the spectrum for natural language processing, right? The real rudimentary basics here, RPA, chatbots, dime a dozen. I'm sure you've heard of virtual assistants like Amazon Alexa, Apple Siri, and then at the very end of this whole thing are virtual agents. These are intelligent machines that function as call center customer care agents receiving inbound calls to service your request. Very rarefied presence of technologies that can do this. IBM Watson and parent company IPsoft's Amelia. It is that Amelia's NLP that drives textual analytics in the EazyML platform. That is why we've been able to make it as powerful as it is. I guess, Mika, you can share it with them. This is all stuff about I'll stop speaking.
Yeah. So I
Any
think,
questions, comments as I let Pranay
yeah,
run further?
I think Pranay, take it
Don't
away.
hesitate. If there are things you want to say, please. Okay, pretty good. Send us emails after you've had time to digest all this. We would do our very best to answer each one in good time.
Hello, everyone. This is Pranay here. I'm sharing my desktop. I hope you all can see the browser pointing to easyml.com. If not, just raise your hand, okay, on the chat. I mean, easyml.com, this is the gateway to the service and its offering. The first thing I would like you guys to do, whether you are using APIs or whether you are using the machine learning web-based portal, is to sign up. I know most of you have already signed up. So you go to the website, click on For Personal, then click on Get Started, right? And then sign up with Google, right? Or you can enter your name, email address, and create a password. Okay. In my case, I do have an account which I've been using, so I can directly log in using my credentials. Right? So it's as simple as that. Sign up, and then when you click on login, it will bring you to this portal where you can then sign in using your Google account. Once you sign in, this would be the landing page. And this is where our journey starts. Okay. But before I dive into the specifics of this entire machine learning pipeline, I would like you to take a look at the easyml.com website again. And I wanted to show you the developers portal. How many of you here are already familiar with the Python libraries for machine learning? Not necessarily EasyML, but machine learning in general, like scikit, pandas, data frame manipulation. So before you could build models, one of the key stages is data preprocessing.
Yes. So what the point that Pranay is making really quick, sorry Pranay, I didn't mean to interrupt, is there are two classes of probably audience here. One are the people who are like, I do XYZ and I could use ML as a tool. I don't know a lot about it. I could use it as a tool to help me with my XYZ and projects thereof. And so they can use the GUI. Don't have to bother with APIs and Python and Panda and all that fun stuff which data scientists learn. And then the other class of people are those who are actually probably data scientists or quasi-data scientists or coming from statistical background that like to use these mechanisms of APIs and code in Python. For them too, this is what Pranay is showing.
Or CS majors.
Right, exactly. Good point. CS major. So there are two classes, and it caters to both at the GUI level for those who want to use it just as a tool and come from other disciplines, and at a detailed API coding level for those who come from computer science or data science and want to use it in that regard. Okay, thanks, Pranay.
Right. So while you are signing up and logging in and coming here to the landing page, I'll give everyone a couple minutes to go through that process while I'll take you through the journey of these API guides. For the audience who are into programming, who come from data science background, who have used Python libraries for machine learning or for data manipulation, you can use EasyML APIs to build models, to test models, to deploy EasyML built models for predictions. So the flow looks something like the following. You may have already seen this. There are these, you got data sets, okay? We are going to use one such data set, that's Titanic Data Set. Some of you may be already familiar with that data set. It's about the passengers who boarded Titanic ship and which one of them survived versus which one of them did not, along with certain attributes for each one of those passengers. For example, what class did they board? How much fare did they pay? What was the gender? What's the age? And so on and so forth. We are going to look at one such data set, Titanic. Okay. Once you have data set at hand, you go through the entire machine learning pipeline, whether it's by means of APIs or through the UI portal. We are looking at both at the moment. You build the models. The EazyML platform builds several models on your behalf in the background and recommends the best one for you, which you deploy to run your predictions. You can deploy with APIs, or you can, go to the web-based portal, look at the models in your repository and use them over and over for running predictions. Where does it fit in the entire scheme of things? So when you have a machine learning exercise, when you have a use case at hand, this is the end-to-end pipeline. In any organization or as a personal consumer or user, you may have data sets in various data sources. You may have it on your laptop, on your local file systems. You may have it on Google Drive. You may have it on Amazon, RDS or S3. There are APIs published by these data vendors, which you can use to pull the data. And you can do your data massaging or data wrangling, as it is called, to join the tables, to merge the tables, pick the information elements that you need, and prepare a data set like Titanic. Okay? And then push it through the EazyML pipeline, which can be stitched together with APIs, or as we will walk through shortly, in the UI. Once you have built the models, you can again use EazyML APIs to get the reports out of EazyML to build visualizations, again using the tools of your choice. So that's where EazyML fits in the entire ecosystem, for a business case or use case for machine learning. So far, so good. Before I start the journey with the web-based UI portal, any questions? If you do, please raise your hands or just write it on the chat window. Deepak, Meeta, Jason will be monitoring and responding to your questions. So here, there are two modes: accelerated mode, detailed mode. Detailed mode is the one recommended for anyone coming here for the first time, and anyone who's interested in knowing step by step what is it that EazyML platform does with your data. Right? We are going to go with detailed mode here. But anytime you have questions about what this particular screen does or stage in the pipeline does, you can always click on help. This help is context sensitive in two senses. Number one, it'll tell you which screen you are on and what that screen does. So it'll have a high level help information as well as you can dive into details. The second, context sensitive in the sense that it gives you information specific to the data set that you are working with and in this particular session. So as we walk through this, you will see those instances of context sensitive help. Anytime you want to abandon the process, come back to the home screen, that's your home button, right? Now, once we go through this process and build the data sets, build the models, you'll find those here in your personal directory repository. Your training data sets, models, prediction data set, they will be all in here. So let's start. We are going to upload the training data that you must have downloaded from the EazyML website.
I'm sorry, Pranay. Everybody should just follow Pranay. I guess it goes without saying. I just wanted to remind everybody to just follow.
Yeah, follow along, please. And remember, this is supervisory machine learning, a fancy way of saying that this machine learning requires training data for the machine to become intelligent about your work so that it can help you predict your work. So that's why it starts with a training data, the file in which the training data. So Pranay, you may want to show what that looks like in an Excel or something.
Yeah, I'm going to show it here right on the EazyML platform. Once we upload the data, we'll be able to see what data looks like. So like Deepak said, it's supervisory machine learning platform. So that means the data in here that we are going to upload, the training data, it's going to have labels, specific labels. In this case, the label is whether the passenger survived or not. So the first column that you're looking at in here, the survived column, is the labels. This is what Deepak was referring to, the training data in supervisory learning. For every data point, you must have a label. That's how machine is going to learn from those labels about the behavioral profile of every one of these individuals, right? And how it affects the survival probability.
So 0 means not survived, 1 means survived the Titanic disaster.
Right, right. And all the attributes of interest, they're all in here. The passenger class, the name of the passenger, the gender, age, whether there were siblings or spouse aboard, parents, children aboard, and the fare. Right? A total of 8 variables, 861 records. Please specify the identifier variable in your data. We know the name is the identity in this case. We'll choose and move along with it. Now in here, the identifier variable does not play a role in the prediction. No, it's a unique identifier for every record. So from machine learning point of view, it's not really a core predictor. So it gets dropped off when you select it. You know. Discard columns, you don't have to worry about it. It's a very useful feature, and we can talk about it in a later setting. So for now, you just skip to the next screen.
You know, the good thing about this is that when the machine takes you to a particular step, it makes a default recommendation. And more likely than not, that recommendation is based on sound statistical analysis of your training data at that step. So you can just proceed with it, knowing fully well that it's going to do a good job on your training data to learn from it so that it can predict better. So you don't have to worry about, oh, what should I do at this step? You can just keep hitting next most of the time. And should you be of the curious type, it's like, why did you select that? Just hit the question mark button at the top, and it's going to tell you in detail why it's making those observations. So, as much as you want to learn, you are welcome to on this platform. It's very transparent, like I said. The motto for EazyML is learn machine learning by doing machine learning. Learn ML by doing it.
So take the default values, and as you become more conversant into it, there are inbuilt checkpoints. So when you take the default value, you do it a couple of times, then you can become more, adventurous and try to change the values a little bit and see how it's reacting.
Right. For example, here, the machine has automatically determined the data types for the variables in your data set. And since you had more than statistically significant number of data points, a total of 861 or so, machine is fairly correct in its determination of various data types, whether they are categorical or numeric. In this case, those are the only types. But there could be more in your data set. So when you click on help, you can see what all different kinds of data types are automatically determined here and what they mean. So anytime you want to learn the lingua franca of the data science, they're all defined in here in the help. Okay. What's a categorical variable, numeric variable, and so on and so forth. These variables are automatically determined by the machine, the types, and then used in the machine model building process. We'll keep moving. Here are some very basic statistics, mean, median, and standard deviation stuff. if you just wanted to get an overview of what are these characteristics of your data set. You can take a pause there on that screen. Outliers removal. If you want to know what outliers are, or if you already know, and if you want to understand what outlier detection techniques the EazyML platform is using, you can always read help. You will know about a couple of algorithms in here, like isolation forest. These are the extreme values which do not fit the norm, which EazyML platform will automatically detect and remove those for you. Well, in this data set, there were no missing values. There is another screen here, which we jumped ahead because there were no missing values in the data set. The screen was about imputation. The EazyML platform would automatically extrapolate or interpolate the missing values for you in case there are holes in your data set in some columns. So we'll go with machine's default recommendations, like Meeta explained many times. You just go with the flow. Machine's default recommendation. It says.
I'm sorry, Pranay. I just wanted to make sure everybody is able to follow. The pace is good. If anybody finds the pace to be too fast, just raise your hand and Pranay will adapt accordingly.
All right, so the following data points will be used for building models. That's the stage 1, data pre-processing. So before you build the model, the very first stage is upload the data and prepare. So that's the first stage. We are almost at the end of that. But before we proceed to building model, an important question in supervisory machine learning is, what is the outcome that you're trying to predict? Well, in this case, we want to predict whether the passenger survived or not. So that's our outcome value. That's it. We are the total number of rows 861. The native predictors in the data set are 6, and the outcome variable selected is survive. So that's the summary of your data processing. Yeah. If you wanted to visualize the data, there is visualization built into the platform, but in the interest of time, I'm going to skip through that. The first stage is complete.
So what you saw here, really quick, is that the training data expects a whole bunch of variables, which Pranay calls predictors. These are the inputs, if you will, to your statistical model, and one output, which we will call the outcome. So given all the inputs in your training data, all the predictors in the data science lingo, it will predict, once the machine gets trained, it will predict the outcome or the output from the model. Okay. So that's the supervisory machine learning that will happen.
All right, so the term predictors and features are used interchangeably. Like Deepak explained what they mean, right, in this context. At this point of time, your data set is processed and ready. You can go to the training data set repository in here. You will see that Titanic train data set is in here. Here's the outcome variable, the upload date is so and so. Let's go back to the flow. I'll keep moving with the second stage. Do you want to continue with building the model? Now we are here, build and train. So the default, of course, yes. If you wanted to upload more and more data set, you can go back to the home screen and upload all the data sets first before starting your journey with the model building process. Here in the stage 2, there are 2 kinds of models that you can build, the predictive models or time series models. This is a predictive analytics challenge. So we go with the default recommendation of the machine because most of the use cases solved by the data scientists happen to be predictive analytics related. Problem type is classification. A classification problem means you are predicting the category as whether survival yes or no, true or false. There are only 2 categories in here, binary classification. But you might as well have multiple categories. For example, performance of a student in the class, excellent versus good versus average versus poor. 4 different categories in there. So classification problem has to do with identifying the classes, predicting the classes, because the outcome variable type is categorical. Do you want EazyML to remove dependent predictors? Again, in some cases it may make sense to say yes to that question and override machine's default recommendation. Okay, you can find details here in the help. For now, we'll just go with the flow, machine's default recommendation. Adding numeric derived predictors. Now here, the machine offers you to add your own derived predictors. So note that the phrase used here is derived predictors as opposed to native predictors. So native predictors are those which are natively present in your data set, like passenger class, fare, the siblings, gender, and so on and so forth. A derived predictor is something which is a combination or derived from these native predictors. If you wanted to do so, you override machine's default recommendation here and define those derived predictors. In some use cases, it makes sense. In this particular challenge, it doesn't. So I'm gonna skip this. Continue with machine's default recommendation. No, I don't want to derive any predictors. By the way, so on that screen, we saw derived predictors for numeric. If your data set happened to have text data, right, text column, then it would allow you to derive various kinds of text derived predictors. For example, sentiments or topics, if you're familiar with topic mining, right? The word vectorization, word to vec, cloud vectors, if you're familiar with those concepts, right? Or it can allow you to add your own concept, and see if the concepts are present in the text and derive categorical variables corresponding to those concepts, maybe for a later presentation. So for now, we have specified what data set, we have specified the problem, it's a classification problem, and we're not going to derive any predictors. We'll go with feature selection, okay? And right after feature selection, well, if there were derived predictors, you would see here additional columns. So here is a final view before we dive into neural networks, support vector machine, random forest, all kinds of models being built in the background. Here's a final look at your data, okay? And then it'll start building the models in the background. So like I said, there are many models being considered and their hyperparameters are being tuned. So you're looking for optimal parameters for those models. And machine is using tenfold cross-validation in here to find the best model among all of these. Then I recommend you the best one in the end. In the end, it's gonna list every single model in there with the performance metric. Well, since this is a classification problem, your performance metric would be accuracy, kappa value, for example. If it was a regression problem, you would see the performance metric to be R-square values, RMSE value. So those are all defined in here. If you wanted to understand what they mean, they're all in here. Right? So if you recall, I said, this provides you help in the context of the data set. For example, for this particular data set, the accuracy is 82%. And in previous screens, if you had, for example, looked at the help for after feature selection, you would have seen features selected for this particular data set. And here, the best model is boosted decision trees with information gain, with 82% accuracy and highest kappa value. Not only does it tell you what all models it built and what does it recommend, it also gives you a very high level overview of what features from your data set? Equivalently, what predictors are most important in making that prediction whether the passenger is going to survive or not?
Yeah, remember we talked about transparency? Here's one facet of it. It's telling you which of your input variables were influential in predicting the outcome or output variable, which is survival. And it's giving you a feel for how influential these are. That's just one facet. You will see many of them, but it's very transparently giving you at every step what matters and what doesn't matter, and trying to win your confidence. Because after all, you are the subject matter experts in your area.
Right. So at this point of time, you completed second stage. Your models are built. So those who are following along with me, you should see your models built too. So we are done with build and train. Okay. Now the next stage is to test, test on your own data set, test data set, run predictions. If you are happy with the predictions, you can move on to deployment. So that's the next stage. At this point of time, you can go and check your repository. You will find your model in here. Okay. So, but in the interest of time, I'm gonna keep moving to the third stage, so that I wanna leave last 5 minutes for additional questions or closing remarks. So we're gonna predict from our test data set. We're gonna choose the model which is the best one recommended by machine. But if you want it, if you were curious to know what other models would have predicted, you can choose those too. There is an option to do that. We'll go with the best one. We'll select our test data file that I had downloaded earlier today. Predictions are ready. Here are the predictions, the last column. And when it happens to be in green, well, in this case, my test data also had the original labels. So in cases where there is original label present in the test data, it tells you how did it perform. So there is accuracy value right there. Now, in case there was a mismatch in the prediction, you would see those in the red color, like that. Otherwise, the good predictions are all labeled in green. Now, here is one of the most important facets of transparency. Deepak has been talking about various different facets of transparency along the way. Machines being transparent in telling you every step of the way what it's doing, telling you what's important, what's not important. But here is the icing on the cake, where it says, do you really want to understand why it predicted the way it did? Default is yes, of course. Now there are several data points. Now machine predicts this particular passenger, let's say, survived. This one survived. This one did not survive. You want to understand why? You choose that data point. Now, if you, okay, behind the scenes, machine did all that its mathematical computation and figures out that, well, this particular passenger. Now, remember, the machine builds the model from the entire training data set, 861 rows. It knows about the passengers in general, across those 861. But when it comes to making predictions, why is it that this particular passenger survived? So if you recall, the most important variable that we had seen was gender. Now, if gender decides pretty much in 57, more than half of the cases, whether the passenger is going to survive or not. But here, if you look, this particular passenger survived because he or she paid 227, whatever was the currency at that point of time for Titanic fare, but that's pretty high. If you look at the entire data set, I'm going to go back to that and I'll show you that this is pretty high. So regardless of the gender, well, in this case, gender happened to be female, but that wasn't the most important one. This is the highest fare anyone paid in the entire, passenger set. So this passenger survived because the fare was pretty hot. While if you look at the second one survived too, and the fare, there is dramatic difference. Why did the second one survive? Well, the second one survived because it's a young 1-year-old female child. It doesn't matter the fare was low or what the class was. It's a young female child. What's the most important thing in here is age and then the gender.
So notice what Pranay just explained here is so critical. Transparency. The machine platform is telling you precisely why it's making a prediction, so that you can then say, oh yeah, that makes sense, or you can say, I never thought about that. It makes sense now that it tells so. So you really learned something in the process. It's as if, and this is the key, your data from an experiment is speaking to you. The machine is very objectively analyzing your data and saying, this is why I'm making these predictions. This is what I inferred from your data. And all that is now giving you insights that you kind of know, and it affirms what you already have known all along as subject matter expert. Or some of these may surprise you, and then when you sit and stare at it, you say, yeah, that's an interesting thing. I wonder why I didn't think of that before. That makes a ton of sense now that I think of it. So you really learned something new in the process by the machine being transparent enough for a local prediction. So I'm making this big distinction here. Earlier, it had given you across all your training data what were the influential input variables that determine the outcome. This one is saying, for that stuff that you're asking me to predict, this is why I'm making that prediction. It's transparent to a fault.
So very important aspect of transparency, telling you locally what was important. For this particular passenger, what was the important factor? In fact, there's another facet of transparency is trace, which I haven't shown you. That's the last thing I'm going to show you, and then I'm going to call it off from my side, is this trace button. When you click on the trace button, you can trace the entire history of your session. Okay. You can trace the entire history of your session. You can go back to...
So how's that helpful? It's helpful because let's say you've done something and you're like, it came out good, but I wish I could have tweaked my training data and tried again, or chose another thing instead of what the machine chose for me. And you do that, and now it's come out with even worse results, and you are saying, I need to go back. What did I do earlier? Let me just go back and see what I did earlier. Let me repeat that so that I at least get to that same state, and then I'll try something else. You can scroll back and forth, debug, troubleshoot, analyze, and be able to intelligently navigate, rather than other ML platforms will not give you this insight. See, so every step of the way, it's transparent to a fault. It's really trying to help you learn ML by doing ML.
Right. So with that, I have given the tour of the entire pipeline. So if you wanted to test with more data set or understand more, you could continue through this pipeline. But at this point of time, I'll say no more predictions. I will take you back to the beginning of the pipeline so that you can play with more data set. That's it. That's how easy it is to go through the entire pipeline. No programming required. So that's what Deepak meant when he said, the EazyML replaces, so machine learning replaces programmer's job. Traditional programs, you feed data and you get the output. The code is something in between which you write. But in the machine learning world, you feed data, the training data in this case, and EazyML platform generates a model, which is equivalent of someone wrote the code, and you feed the test data to the model, and it generates the...
So Pranay, did you also go over the accelerated mode? I know we went through the detailed mode, but did we give any questions? Anybody has any questions? Now we can talk.
Yeah, we didn't have time.
We didn't have.
So accelerated mode makes it less painful because
Yeah,
it
you
just
don't. It just
rushes
goes
through all the
rushes through
steps.
everything quickly.
Instead of step by step like it went through, it just rushes through. But again, for the curious mind, you may want to go step by step and actually see what the machine is doing so that you feel comfortable with what it's doing to your data.
Okay, so Kyle is asking, can you do unsupervised learning on this platform?
So yes, Kyle, on textual analytics you can, and maybe we should do that NLP for a follow-on session. Like I said, for digital marketers, sentiment's important for how a product from a company is being received in the market, in the consumer market. And that sentiment is, of course, unsupervised, pre-trained model. So you can just build on it. There are others as well. But we'll keep away from that for the purposes of this session, because I know otherwise it will take another hour or so.
To explain, yes. Any other questions? Okay. So anybody, if anybody wants premium access, my email is here. You can reach out to me. Let me know. Also, try this. Let me know if you have any questions. If you get stuck on something, feel free to reach out to us. We would love to know.
I know there is a kind of hesitation when you sit down in front of it, although many of you would have walked through this whole process. That helps. But when you sit down and you're saying, how do I construct training data? How do I get started? Please feel free to reach out to Meeta and we will help you get started, because we really want people to use the power of an intelligent machine and not just reserve it for those elite few called data science.
Yeah. And the session is being recorded, so Kyle is going to make it available to everybody. And you guys can go over again, go to the tutorial section. There is a ton of information there. And I think that once you view a couple of videos, there is a YouTube channel. Pranay, if you can go down. I guess the YouTube channel also has a lot of information. EazyML YouTube channel has a lot of information. Watch a couple of tutorials, and you'll get the hang of it. It really is very, very easy to learn. The mantra is learn machine learning by doing machine learning, applied learning. You don't need any background in coding. You don't need any background in software engineering. You can just get started right away. And we have made everything consolidated on the website, from training data to test data to tutorial video and everything. And whatever, if there is anything that you don't understand, you're very welcome to reach out to me or anybody on our team, and we'll be very happy to help you.
Thank you, Kyle. A loud shout out to Kyle for arranging this. Much appreciated.
Yeah, Kyle, thank you. Thank you so much, Kyle. But we appreciate it. We appreciate all the work that you did and reaching out to everybody and advertising it, and everybody who came to attend it. I hope that it's helpful to you guys. Until next time.
Yeah.
Kyle, anything?
No, I mean, thank you guys so much. Yeah, I think it was helpful, and I'll definitely make sure everyone has information to reach out to you and whatnot. Yeah, and we'll certainly be in touch. Thank you guys.
Right.
And thanks everyone for coming.
Yeah, thank you. Bye-bye.
All right, bye.
Bye.